I'm Katie.
I'm Darby.
I'm Allison.
And we're going to teach you about swimming pools.
Sweet.
All right, we're going to talk about the pH.
The total alkalinity.
How Bo cleans a pool with unopposable hose.
And why you add chlorine.
Yeah, so stay tuned, especially for the credits. There's some pretty cool people in our video. We would like to thank Justin from the pool place, Rising Sun. He's really cool, but really awkward.
Kind of like us.
Kind of like us. Thank you and God bless. Keep it 420. Blaze it.
Main things to test in the pool water that we test for are chlorine and then the pH, which obviously is the acidity level of the water. pH scale from a 0 to a 14, 7's as neutral as you can be. So in pool water, swimming water, drinking water, bathing water, you want it between like a 7.2 to a 7.6. This is as neutral as you can get.
Okay, I'm taking a pH test right now, among other things. Pool water, so that's cool, I guess. IDK Blaze it. pH is probably somewhere around 6.8, and a regular pool water needs to be around 7.2 to 7.6, so it's close. Yay.
So there's a couple things you need to do to keep that in range. Main thing at the beginning of the season we have a lot of customers do is add a decent amount of sodium bicarbonate, which is what we call alkalinity increaser, which raises the total alkalinity of the water. Total alkalinity, again, basically is the water's ability to absorb acids and bases, mainly rain,
Hey guys, so alkalinity is a term that we use a lot when we talk about pool water. We know that when we create a pool, when we prep it for our use, we create a buffer solution. We create a buffer solution with the alkalinity increaser we stick in the pool. And when we say alkalinity, that's really just a measure of how strong that buffer solution is. In other words, how much is the solution able to resist a change in pH? And a strong alkalinity would reflect a strong resistance to a pH change.
level, which typically, in tap water is a very low total alkalinity level, and so does, most rain, especially acidic rain. Again, at the beginning of the season, it's going to be low. So we raise that up. If we don't, and that buffer is at a lower level, pH tends to fluctuate quite a bit. So again, it kind of helps lock that pH in place, absorb, rain. If it rains a lot and it's an acidic rain or a basic rain, then the pH isn't going to fluctuate too much because that sodium bicarb is in there to keep that prevent that from happening. And again, that's based on parts per million. So most pools, you want at about a 100 parts per million, which we test for. We have plenty of testing equipment to test for that and adjust it as needed.
So for Allie's pool, her pool is 18,000 gallons of water. That's a lot of milk jugs. The proper alkalinity for a pool is between 80 and 100 parts per million of alkalinity increaser in the water. So to get that around that range, we had to put 14 pounds of alkalinity increaser in her pool.
Allison Towie fights with 12 pounds of alkalinity increaser.
Got it.
Ah, she takes it out of the box. She sets it down.
Oh, watch out.
The excess stuff goes into the pool. This is so exciting.
There's a rip in the bag. It's getting in the There we go.
Her hand goes through the bag. Wait for it.
Are you excited?
Are you ready to be buffered? Ah. The sweet smell of a buffered pH. Elfie.
Consider yourself buffered.
Rainwater is acidic, and when it's added in large amounts to pool water, it will bring the pH down of the pool. The day before Darby and Katie came over to my house to work with the pool, I had tested the water before it started raining. The pH was about 6.9, and after the rain came, Darby and Katie came over to my house, and we tested it again, and it was about 6.8, showing that the rainwater did actually decrease the pH. Also, the total alkalinity of the pool decreased with the rain. Before it was about 80 parts per million, and afterwards it was about 75 parts per million. When the alkalinity is where it's supposed to be, the pH will balance out, and it'll stabilize generally around 7.2, 7.6. If it's too low, below that 80 parts per million, the water will turn green, metals will start to corrode, and in order to change that, or to increase it, you need to add sodium bicarbonate, which is the alkalinity increaser, which we added to my pool. If it's above that 100 parts per million mark, the alkalinity is too high, and the water will become cloudy, and the pH will change rapidly. And in order to fix that, you need to add acid, which will take, it could take up to 2 months to fix. So, blaze it.
Okay. All right. So basic pool chemistry. I'm acting like I'm talking to somebody that's not straight front. So yeah, you know, chlorine is what keeps the water clean, and it's all based on parts per million. So you know, to maintain chlorine levels between a 1 and a 3 parts per million, basically, is what you need to keep the water clean. You know, chlorine comes in a number of different forms. Main thing, like granular chlorine, is a calcium hypochlorite, and that's used to shock a pool, bring chlorine levels up high for a short amount of time, and as it comes back down, you know, it kills off algae, kills off bacteria. Chlorine, I guess the main, you know, chemical in there is chloride, which is obviously an element. So again, to maintain, use things like chlorine tablets, like a trichlor tablet, and that maintains, you know, parts per million between a 1 and a 3. As long as that's the case, you know, things like bacteria, algae, that kind of stuff is going to stay killed off. Keep the water clean. When chlorine levels get low, things like algae and bacteria start growing. That's when water gets cloudy and starts getting dirty. So essentially, it just keeps the water clean. And that's obviously the main chemical that you have in the pool.
So, chlorination is a really important part of cleaning your swimming pool and preparing it for use. We know that there are a lot of bacteria and protozoa that live in water, especially because Allie's pool is surrounded by a lot of trees. Also, because your human body is entering water, and there is stuff on your human body that gets in the water that needs to be killed to make it safe to swim. So, chlorination is a process that takes care of all of that and really cleans your water. There are about 2 ways you can go about chlorinating your pool. One is injecting chlorine gas directly into the pool, which doesn't really make a lot of sense for the common pool user, because we know that when you dissolve a gas in water, you need a lot of pressure to do that, and you can't really get that in an outdoor pool. So, for most pool users, including Allie, the preferred method is to dissolve a calcium chloride tablet in the pool water.
Katie is pushing around chlorine.
Should I sing like an Italian gondolier?
Allie used a tablet about 3 inches around, which is that big, and this method produces the the hypochlorite ion. And the hypochlorite ion is what has a reaction with sunlight to actually kill the bacteria. You might think that it's the chlorine itself that does the cleaning of the pool, but it's the hypochlorite ion that breaks down in sunlight and produces a free radical on an oxygen atom. And the free radical on the oxygen atom, we know from Miss Dudley's AP chemistry class, is very dangerous to a lot of life forms. And that's what kills the bacteria and protozoa in the water and keeps it very clean.
Please observe this chlorine tablet. It is a 3-inch tablet, and it's adding chlorine to the pool. That's why it's called a chlorine tablet, because it's made of chlorine.
It's a solid compound of calcium. No. Yes, calcium chloride.
Yes.
Yeah.
Yeah.
Otherwise, chlorine gas would be, well, a gas at room temperature.
But this isn't a gas, because you can see it in the pool.
However, as we push it along the bottom of the pool, if you look closely, you can see the calcium and chlorine dissociating, and you can see the chlorine gas bubbles being dissolved in the water.
Science.
This method is really good for the common pool user because the chlorine tablets are relatively inexpensive and they leave behind a few deposits except for the calcium from the calcium chloride molecule, and the chloride ion, once it's dissociated, is completely harmless. If you look closely in the video that we show the tablet dissolving, you can see the chlorine gas coming off of the tablet and dissolving in the water that way. We almost forgot that you should not enter the pool during chlorination. It's a very dangerous process. We've been talking about the free radical on the oxygen, and exposing your body to that will cause hair whitening and it will kill your hair follicles. So if you'd like your hair to fall out, by all means, please proceed to enter the pool during chlorination. But I think that a lot of you like your hair, so you should wait at least 8 hours for a pool like Allie's that has 18,000 gallons. That's a lot of milk jugs. You want to wait until the concentration is back around 3 parts per million for the chlorine for you to enter the pool.
Most acidic rain has either sulfuric acid or nitric acid in it, and adding that to the chlorinated water will lessen the effects of the chlorine and therefore making the pool less disinfected. Indoor pools generally need less alkalinity increaser and less chlorine because they're not affected by things such as the rainwater, which will decrease the outdoor pool's pH. They're not affected by folic acid from leaves. There's usually not as much debris in the indoor pool, so it's not affected by the bacteria that's included with those debris. A new trend that has been arising is saltwater pools, and saltwater pools don't need any chlorine because the salt water itself will disinfect the water.
So again, main things, chlorine and the pH by far the 2 most important aspects of the pool chemistry that we test for, and then a couple other things that, that kind of keep those things in range.